Welcome to another compelling episode of Auburn Online's Tiger Bytes. We're here with Rachel Prado from the Department of Chemistry
and Biochemistry.
At some point, you can explain the difference in those things to me. Rachel has a unique distinction of being the first guest who actually volunteered to be on Tiger Bytes, not just recruited or arm twisted.
No, I was a big fan. I saw a lot of I've been watching the podcast, and I was like, I would love to come and talk about my experience working with Auburn Online and all the cool things that I was able to do. So I am so excited to be here.
Awesome. And you said you're a big fan of what Auburn Online provides?
Yes. Yeah, absolutely. We started working together about 3 years ago when I had an idea that was really crazy. And I kind of just talked to people until someone said, I think you need to talk to Chandra with Auburn Online. And so Chandra and I connected, and she had just been to a conference that had discussed some of the similar things, because I wanted to create something that students could rotate kind of in their screen. And so she helped. She told me about the opportunity for the VR grants. That was the first round that they did. So I submitted an application, and that's how I kind of started working with Auburn Online.
Super.
Yeah.
So that's where I wanted to start, actually. Could you explain the main objectives of your AUX 2021 project, which was called, I'll mess up this one word for sure, naming R or S
stereoisomers. Yeah, absolutely.
Close.
Yeah, you're good.
With virtual reality training and how it aims to enhance students' understanding of stereochemistry.
Yeah, absolutely. So I teach general and organic chemistry. So in organic chemistry, when I was teaching for the first time, everything was going really great until we hit stereochemistry. And it's this,
which is,
it's this idea that you have molecules just like our hands. So if you put your two hands together, your hands are enantiomers of one another, meaning that they're non-superimposable mirror images. So like if you and you're looking at your hands, you're always either looking at the backs of them or like a palm in the back, but they're never quite lined up perfectly. So this is a non-superimposable mirror image. And our bodies use enantiomers in our amino acids. So this is really important, especially for biomedical science majors and any student who's going into the medical field who has to take biochemistry. They need to understand what stereochemistry is and why it's important. But when I would teach it, they would just hit this brick wall where students would have trouble imagining molecules in their mind's eye and rotating it. So kind of that spatial ability. It was really difficult. So I kept talking about my problems, and someone connected me with Auburn Online. And at first I wanted to create just this VR where students maybe could put on a headset and then it could train. But, when I kind of met with Auburn Online and they asked like, what were my goals? Well, my goal was for every student in my class to be able to understand it. So they really helped me develop not just an activity, not just a VR one, but it's an actual a walkthrough where students go from not knowing anything about stereochemistry to being able to identify an amino acid, whether it's R and S, and be really confident with that. So that was kind of our goal. And we created some really incredible, what we call our gold star models for students.
So what does R and S refer to?
Yeah, absolutely. So inside of, at least for organic chemistry 1, just the smallest level, we have molecules, and they have a particular 3-dimensional arrangement. And in order to tell the difference between two enantiomers, and these are those non-superimposable mirror images, you can almost think of them like twins, right? You have twin A and twin B, but instead of A and B, we call them R and S. And this comes from a nomenclature system from Kahn, Ingold, Prelog. So they need to go through 3 different steps in order to determine whether a stereocenter is R or S. So we built kind of this activity that walks students through that process. And in the process, the hardest part is definitely to rotate the molecule in their mind's eye, because on the paper, you have this bond line structure and it's 2-dimensional, but they need to understand like a wedge is coming towards me and a dash is going away from me. So what the coolest part of the project was we created the bond line model on the left and then a 3-dimensional model on the right. So when you rotate, they both rotate together to kind of help students really, really solidify that connection. So I have never seen another model kind of help students bridge the 2-dimensional representation and what it would look like in 3-dimensional representation.
Do you have colleagues either at Auburn or other schools who are interested in using what you've created?
Yeah, absolutely. So right now we've been in pilot phases and we're also still building a website, but eventually we would like this to be nationwide. I have a colleague who helped me, a biochemist, Dr. Falco. She is now at Bard Early College out in DC. So we collaborate together. She was previously at Auburn, and I also make this available to my Auburn colleagues if they'd like to use it in their class.
Cool. So I think you kind of addressed this, but let me run it past Jenny. What challenges do students typically face when learning about stereochemistry, and how does your virtual reality training address those challenges?
Yeah, I would say the biggest challenge they have is it gives them a headache when they're trying to learn this, because especially if students play a lot of video games like Minecraft and they're used to kind of rotating objects, typically they kind of understand it right away and can really jump in. Students who aren't used to thinking about things and rotating them in their mind's eye, they find it extremely difficult. And there's also kind of a mind-body connection. So sometimes like in class we'll do different ways, but I can't reach every student that way. So developing this and helping them guide through, that's really what I hope all students are going to be helped. And then this is such like almost like a linchpin in organic chemistry, because if you can't get stereochemistry, then the rest of the mechanisms you're trying to learn are very difficult.
Have you thought about incorporating any gamification type elements?
Yeah, absolutely. So that is one thing that Auburn Online is experts at. They have gamification. We have badges. So we have a main character, Dr. Daly. She kind of guides students through the process. And then after each scene, they earn a badge. Like can I now identify chiral carbons? And then each step they earn a badge. And they have a notebook that they can kind of read the notes through. So yeah, there's a lot of gamification inside that I learned a lot about, because I wasn't as familiar. Like I'm a chemist. I'm not a designer.
Right. And what sort of feedback have you gotten from students on this?
Yeah, absolutely. So our pilot led with around 300 or so students, and over 80%, 85% strongly agreed that using this walkthrough helped them with 3-dimensional thinking and spatial thinking. And my students in class all the time will reference Dr. Daly, and at first I'm like, who? And I'm like, oh yeah, the activity. So they really like it, and they love Dr. Daly. Like it was fun to create kind of that process with all of my collaborators.
Have the grades improved?
Yeah, I think that's really the next step, is to kind of think about if a student uses this versus doesn't, what does their grade look like? But there's kind of this idea when you're researching, you don't want to do harm to students.
Right.
So it's really hard to say, like, I don't want some students to have this resource. So that's kind of where we're thinking about, how do we actually measure this input or this outcome?
You could look at grades from previous semesters.
Yeah, that's very true.
It doesn't have to be a super robust experimental design with a control group.
That's very true.
Yeah. So what future plans do you have for integrating immersive learning technologies into your teaching, and how do you see these technologies evolving in the field of chemistry education?
Oh, wow. Yeah. In chemistry education, I would love to see them evolve where the tools are easier for chemists to use, because right now when we design this, like I need to work with an artist and someone who's a programmer. Like the tools right now are not where I could actually go out and do this. So I would hope in the future the tools are a little bit easier, that you could almost create more. I have a couple of ideas that hopefully for future grant rounds, that we could expand this into general chemistry as well.
So could you talk a little bit about the difference between chemistry and biochemistry?
I consider biochemistry kind of a cross between chemistry and biology. It focuses a lot on our enzymes in our bodies and different reactions that occur, like specifically inside the body.
So if you're dealing with living beings, it's biochemistry.
Yes, absolutely. Like in cells, how does a reaction happen? Like which atom specifically? What's the mechanism? Why do sometimes biochemists will study why a enzyme kind of goes haywire and causes cancer? Like they really understanding those underlying fundamental problems can help other scientists develop drugs for that.
And if we're talking about hydrogen and oxygen coming together to form water,
Yes.
that would just be chemistry.
That's more on chemistry side.
Okay.
Yes, absolutely. That's a great way to think about it.
But if we're thinking about how the water then goes into the body
Yes.
and provides certain benefits, that would be biochemistry.
Yes, absolutely.
Great. So the difference between biology and chemistry is basically at the teeth. The teeth are the border.
I guess so, yeah.
Okay.
I mean, because you have some molecular biology, which is, sometimes a candidate will come and they are interviewing at jobs in chemistry departments and biology departments because they're kind of at that border. So I think that it's an exciting frontier now. It's kind of the borders are getting a little blurry.
How long have you been at Auburn?
So I started at Auburn in fall of 2019, right before the pandemic.
That's sort of what I wanted to ask you about. When the pandemic hits and all of a sudden we can't be face-to-face all that much, what sort of steps did you take to help students get through that?
Yeah, that was so challenging for students and for faculty because it was right at spring break where we kind of got the email, hey, we're not coming back to campus.
Right.
And I had just written and printed exam 2.
Oh, wow.
I was like, wonderful. All of this work was just, so we had to pivot. And I do remember Big EO and the Auburn Online folks, they were there on Sunday helping faculty.
Slammed, yeah.
Yes, they had open office hours. I would just pop in and be like, how do I do this? So I, because my classes were 200 and 300 students, I did Zoom for fall of 2021 and then spring of 2020. Fall of 2020. Spring of 2021, we were hybrid. But for Zoom, I really made it a point to always keep my camera on, utilize the chat. And honestly, students ask way more questions when they could write it in chat.
So what inspired you to implement a flipped classroom model in your chemistry course? And how do you think this approach translates to an online teaching environment?
Yeah, absolutely. So actually, COVID is the reason that I flipped my class because I was forced to record these videos so that when I was in class, I could help students work through the problems. So once I had the videos in place, what that meant was I could really focus in class on designing problems that students could work through on their own. So actually, I take those same videos that my flipped class would have, and I use those for my online students. So my online students are getting almost the exact same experience. And then I have problem solving, recitation worksheets that I have created videos for the solution. So, and then students can come to my virtual office hours and we can work through the problems just like we would in class. So I think it helps my online teaching in that the students would get the same videos no matter what. So the content is not different between online and in person. The only difference is the in-person students would get more problem-solving sessions in class.
I had a similar experience teaching a doctoral seminar in research design. And historically, it's a 3-hour class. The first half of the class, I would basically lecture, take a break, come back and talk about their projects that they're developing. And so when we were allowed to go to the hybrid environment, they said, cut your face-to-face time in half. I started recording those lectures, and all we would do in person was talk about their projects. Well, I was surprised to find that the students really liked having those lectures recorded because if you're doing it in person and they miss a point, they really have no way to recapture that point. And a lot of them, they'd watch it on regular speed once, and then they'd go back and watch it on 1.5 speed to kind of refresh their memory, but not take up as much time.
Yeah.
And of course, they could go to a particular topic if they were confused about
Yeah,
that
absolutely.
topic.
My students say very similar things. They like having the videos to like pause and write something down.
Right.
They can't pause in real life. I can't stop for
Oh,
every little
Professor,
thing.
could you hold on for a second while I write that down?
Yeah, it's like we have to keep going in
Right.
class. But so I've heard very similar things.
Probably means it's a generalizable type situation.
Yeah.
And, you know, like you, after the pandemic was over, I kept using those videos
Yes.
because the reaction to them had been so good. So,
Yeah.
you know, we could think about COVID as obviously a horrible situation, but it did inspire some
Yes.
innovations that are kind of the silver lining of
Oh,
the whole
yes.
thing.
And I kept a Zoom office hour after, 8 p.m.
Mm-hmm.
because I want students to know, like, I'm available if they can't find any other time. And then was like, I'm in the comfort of my home. I can, take this Zoom call. So it gives students extra times, and it's something that was good from the pandemic.
So how do you ensure that students feel a sense of belonging and engagement in an online setting similar to what they would get in an in-person situation?
Yeah, that's a great question. It's difficult because the first time that I taught the online class, I did not have any type of discussion board. And the feedback that I received was I didn't feel like I was a part of a community. So I utilize the discussion board every week. Students know each chapter has its own discussion board that they need to post. And then I require responses to like 3 other students. And that has been very helpful in creating community. And students get to know one another. They kind of look for the responses, and they actually make friends in the class.
Oh, cool.
So I think adding a discussion board has been very helpful. And reading what they come up with is just, sometimes I've used it in my own class. Like the way that a student like explained it, that how they understood, was like, oh, this makes sense. Like, I'm going to steal it. So
Now, do you use just the Canvas discussion boards, or do you use one of the programs that's available to upgrade it?
I just use the Canvas discussion board, but I should look into I'm always trying to like kind of do something a little bit better each semester.
Yeah, I've been using Harmonize the last couple semesters, and it's gone really well. It's a lot more flexible, I think, than the Canvas discussion boards. And one of the things I have them do is when they respond to their peers, they do it by video, which I don't think Canvas allows.
I think you could record a video, but it's definitely clunkier.
Yeah, this is really simple.
Yes.
And it gets students a lot more comfortable speaking in front of a camera.
Yeah, I'll definitely have to look into that. Thank you.
And Auburn has a site license for it, so the students don't have to pay.
Look, I come on a podcast and leave with new information.
That's what it should be, right? That's why you're such a big fan of this podcast.
I love it so much.
It delivers value. Can you share any feedback from students about their experiences in your online courses, particularly in terms of belonging and comfort?
But I would say students give really great feedback on that. I structure my classes. I have a game plan. I send it out every week. It's always in the same order. A lot of students
they love consistency.
So, and they really feel like, as I'm talking to them through these videos, and I have 2 types of videos. I have the content videos, and then I have my practice problem videos where I talk about the most common mistake. If you made a mistake, it's okay. So they've really commented and given me feedback that they really love the emphasis of like mistakes are okay, and kind of connecting chemistry to the real world, because several students will tell me like, why do I have to take this class? I'm like, this is why it's important. So when students tell me, I think it's the biggest compliment when they're like, okay, I kind of like chemistry now. I'm like, yes.
Well, we're just about out of time.
Yeah.
Thank you, Rachel, for being here.
Thank you so much for having me.
Absolutely. Thank you for joining us for this episode of Tiger Bytes. We hope you enjoyed the conversation and gained some valuable insights. Please like, subscribe, and share this podcast with your friends and colleagues. You can find us on all major platforms, and keep learning, keep growing, and we'll see you next time on Tiger Bytes.